Welcome to my presentation. In this presentation, let us try to solve system of linear equations using matrices. So let's say we have a system of linear equations of this type. x1 plus 3x2 is equal to -1. 2x1 minus x2 is equal to 3. And we want to be able to solve for x1 and x2. The variables here are x1 and x2. Let's break these down into these different steps, and we will try to follow the steps to be able to arrive at the answer in a logical manner. From here, from the system of linear equations, we can write the augmented matrix, isn't it? We pick the coefficients of x1 and x2 in equations 1 and 2. This is equation number 1. This is equation number 2. The augmented matrix looks like this: 1, 3, -1, 2, -1, 3. And then if I were to draw a line here, this side here, 1, 3, 2, -1, is the coefficient matrix of are the coefficients of x1 and x2. So if I were to pick just the coefficients here, and if I were to express this given system of linear equations, I can write that out in this format: 1, 3, 2, -1, and then the variable terms here, I can write that as a matrix x1 and x2, and then is equal to the constant numbers on the other side are -1 and 3, like that. So this is of the form a times x is equal to b, isn't it? We want to go find the values of these unknown quantities. We want to find x1 and x2, and that's where we are right now. So to do this, I'm going to use the elimination method to find the values of x1 and x2. I'm going to use the Gaussian elimination method. Let me write that as step 2. Step number 2. So we will use Gaussian elimination method. Gaussian elimination method. And then in this method, we're going to work with the coefficient matrix. We're going to work with the we're going to work with the augmented matrix, and the way to do that is as follows: we take 1, 3, -1, 2, -1, 3, right? And in this augmented matrix, we are interested in obtaining a matrix on the left hand side, which has ones in the major diagonal, like this. 1, I'll call this as A, I'll call this as B, and then 0, 1, C, like that. This is how we want it. We want ones along the major diagonal, we want zeros below the diagonal, and we can have any other terms on the other side, above the diagonal, and then on the other side of the line as well. So let us use this to see if we can arrive at that in a logical manner. And this is what is called the Gaussian method, and we'll use the elimination. Since we are eliminating a few terms, we call that as the Gaussian elimination method. So in here we already have 1 in the first row, first column. The one which we want to work with right now is this location. We want to make this location equal to 0, and to achieve that, we're going to do the following things: 1, 3, negative 1. The first row comes as is. The new R2 is going to be equal to negative 2R1 plus R2. If we do that, we should be able to get that location as equal to 0. And the way to do that is as follows. Negative 2 times 1 plus 2, that is equal to 0. Let me erase these and then I'll come back and then write them in a minute. And then we have negative 2 times 3 minus 1, which is negative 6, plus negative 1, which is negative 7. And then the third one here is negative 2 times negative 1 plus 3. That's going to be equal to 2 plus 3, which is equal to 5. And the terms we have just above these are 3 and negative 1, isn't it? So we can draw this line here. And if we were to write this one out in a clean manner, it is going to look like this. 1, 3, negative 1, 0, negative 7, and 5, like that. And now, if we were to draw a line along the major diagonal to see where we are on the finish line, we got zeros below the diagonal, and the next step what we want to do is make this location equal to 1, and then we would have achieved what we want to do. So let's try that. So to get a 1 there, we're going to do the following operation. The first row comes down as is, 1, 3, negative 1. The new R2, we can achieve 1 in that location by taking the existing R2 and dividing by negative 7. Since we have a negative 7 in second row, second column, if we were to divide it by a number negative 7, the value is going to be equal to 1. So 0 divided by negative 7 is equal to 0. And then negative 7 divided by negative 7 is equal to 1. And then 5 divided by negative 7 is going to be equal to negative 5 over 7, like that. Okay. Then if we were to write it in a clean manner, this is how it's going to look like. 1, 3, negative 1, 0, 1, negative 5 over 7, like that. Okay. So as we now let us draw these lines along the major diagonal. We wanted ones along the major diagonal, we wanted zeros below the major diagonal, and then we are ready to now read or find the values of x1 and x2 in this case. So the way to read that is as follows. In fact, the final matrix what we have here, this one here, this augmented matrix, from this augmented matrix we can read out the answers, or we can write that in a system of linear equations format and find the values of x1 and x2. So the way we can write it out is as follows. In here, these are the coefficients of x1, these are the coefficients of x2, and the numbers on the other side of the line are the constant numbers. So therefore we can write this as x1, 1x1 or just x1 plus 3x, let me write it a little bit more clear, x1 plus 3x2 is equal to negative 1, 0x1 plus x2, I don't need to write the x1 then, x2 is equal to negative 5 over 7. From here we have the value of x2, we have the value of x2 as negative 5 over 7. Okay, this is one answer for us. To find the value of x1, we're going to substitute it into this first equation, and that first equation is wherever we see x2, we will substitute negative 5 over 7. x1 plus 3 times negative 5 over 7 is equal to negative 1. We want to find the value of x1. So therefore x1 is going to be equal to negative 1 plus 3 times 5 is 15 divided by 7. I just simplified 3 times 5 over 7 with a negative sign. When we bring it over to the other side of the equal to sign, it becomes a positive sign. Or we are using the addition property to be able to simplify that. So in here now, we can take a common denominator. 7 is a common denominator. Negative 7 plus 15. Negative 7 plus 15 is going to be equal to positive 8 over 7. Therefore, the value of x1 is 8 over 7, and the value of x2 is negative 5 over 7. Therefore, the solution here we are looking for is x1 is equal to negative 5 over 7, and x2 is equal to positive 8 over 7. Okay? So this is the way we want to be able to solve this system of linear equations using Gaussian elimination method. I want to continue this problem and then explain a little bit more. I want to also explain how we can draw a graph related to this, and I'm going to show that in part 2 of my presentation. I'll call that as part 2 of my presentation. We'll call this as part 1 of the presentation, and in the next part we will solve the same example problem, and this time we will use we will show you graphically as to how we can arrive at the same answer. In my next presentation, please look for part 2 to solve this system of linear equations using graphical method.